Okay, so we're here in Lexington, Massachusetts, the birthplace of the American Revolution. The British came here to get our ammo about 250 years ago, and they did not succeed. They retreated back to Boston Harbor. And we're joined by a man who's had a storied career in generating American sea power, building some of the most complex warships we have, training and leading a generation of naval architects and marine engineers. And Tim, you invited Rick. I'm so excited about the conversation that we're about to have.
I've known Rick for a long time, but Rick has been part of designing and building some of the most interesting ships in the world. And we're talking about the DDG-51s. We're talking about LPDs, LHAs and Ds. We're talking about carriers, subs. He's done all that stuff. Almost 40 years working in the shipbuilding sector. But just as interestingly is Rick's been really involved in the area around shipbuilding. And so we're talking about, like the Society of Naval Architects and Marine Engineers, SNAME, we call it. He's been the president of SNAME. He's held a bunch of other leadership positions in things like NSRP. So Rick's perspective not only represents, the things that have been going on, at the deck plate level in shipyards for the last 4 decades, but he's also thinking about, that transition to the next 4 decades. And so I can't wait to hear what his thoughts are on some of the stuff we can talk about today.
Yeah, and we're going to get into some discussion about ship design, about keeping your design simple, about welding, about cabling, and about really, I think, some of the most important cost and schedule drivers that we're seeing in the yards right now. And that's why we brought Rick in, and I'm excited for the conversation.
Yeah, absolutely. And I personally can't wait to hear what he has to say about AI, computer usage, electronics, that kind of thing, the future of ship platforms as we know them.
Okay, let's do it.
Let's do this.
Welcome to Rebuilding the Fleet, where we engage the people, voices, and ideas behind America's maritime reboot at the intersection of technology and manufacturing. I'm Austin Gray, former Navy intelligence officer and co-founder of Blue Water Autonomy.
I'm Tim Glenatsis, and I've been building ships for the U.S. Navy and the commercial market for 25 years. From amphibs to destroyers, and now the unmanned warships of the U.S. Navy's future fleet, it's time for some shipbuilding.
Here we go.
Okay, welcome to the show, Rick Spaulding. Thank you very much for joining us, coming all the way up here to Lexington.
Thank you, Tim, and thank you, Austin. I really, really appreciate being invited. I look forward to our conversation today.
We have a whole bunch of really interesting stuff we cannot wait to hear your perspective on, and super thankful you made it up.
Sounds good. Thank you.
So, Rick, I think we jump right in kind of with the core of what we're here for. You've had an amazing career generating American maritime power and sea power from people to steel. Just tell me what's the thing you're most proud of and you learned the most from building American sea power?
The thing I'm most proud of, actually, is to have had the opportunity to spend a career of nearly 40 years working in the industry, building warships, and also commercial ships. The thing that I learned is you can't be successful in this business at all without having a good foundation of a plan. You got to have an executable plan. And we all saw through the years, the programs that were successful were the programs that had a solid plan that was well laid out, that was executable, and could be accomplished by the team that you had. So executability to me is more than just can I put people on the job and go do the work. I've got to have the materials, I've got to have the drawings, I've got to have, of course, the labor resources, but the labor resources have to have the right skills. I have to have the footprint, and I have to make sure I've set a drumbeat for that program that we know from past experience we can accomplish.
And what kind of warships and what kind of commercial ships?
My involvement has been in aircraft carriers, submarines, amphibious assault ships,
big boys,
destroyers, and Coast Guard cutters, the big boys.
Yeah, the when I think about obviously that mix of ship is really interesting, but the way that you approach it, you talked about a very disciplined, plan-based approach. And we're seeing a lot of I'd say confluence between that traditional approach and the need for speed right now. When you think about those two things, how do you
The need for speed. And we see the results of the need for speed, right? We see us starting to build ships without a complete plan, without a complete design, and even without having all the requirements locked down. And so I do think that there's a need for speed, and we have to figure out how we increase the production pace in our industry, right? But if you're going to increase the production pace, you've got to start by laying the groundwork and making sure that you've got all the basic elements in place, right? Once you get those in place and you've got a plan that you know you can execute, and you've got the supply base lined up, so you make sure you've got parts when you need them, I believe that this industry can take off. The other piece that we're seeing is that the complexity of our vessels is getting more and more difficult, right? When I started building ships, they were a whole heck of a lot different than they are today. We had very few signals on a warship. Valves were operated manually, maybe with some remote operations, but you sure as heck didn't have the capability to push a button and open valves all over the ship. And so the result of all that technology means that you've got to have cables installed earlier, you've got to have the databases set up, you've got to have the software set up, and you got to start testing way, way early in the program. If you wait until after the ship's in the water, you're not going to get it done.
So the cabling point is super interesting. Do you think there's like a way to measure how much more cabling work or how much more cable is on a ship today than say 2 decades ago?
Yes. Of course
what's your swag? Like 50% more, or
I'd say probably 150% more. Yeah, absolutely.
Which tells you why it's harder to build.
Yeah, it's got to be.
Yeah, it's miles.
Yeah.
Well, and you have actually, it's a great segue into that question. How did you get into this industry in general? Because the answer to that question sort of dates you in terms of like how much things have changed. How'd you get into this industry in the beginning? And
okay. So as a kid, I grew up in northern Michigan, and I grew up on the Great Lakes, and so I was kind of a nerdy kid who liked to hang around the water and watch the ships go by, and so I've always been interested in naval architecture, or at least ships. I didn't know what a naval architect was until I met one, and I went off and got the education, and I really, really wanted to get into shipbuilding because I felt like being in shipbuilding, to get your hands on and touch these big vessels and deal with the complexity of those. Big engines, big machine shops, all that kind of stuff fascinate me. So it's really how I got into the business. But once I got into the business, for me, it's almost a disease. It's hard for me to get back out of it.
Yeah, right.
So I absolutely love it.
The only disease you love.
Yeah, that's right. That's exactly right.
Maybe America will catch the disease.
Yeah.
Yeah, there's a lot going on with that.
Yeah.
And so what do you think is misunderstood about our ecosystem?
What I think is misunderstood is the need for the right skilled labor. I think we have a real problem getting the production skills and the design skills that we need to have. And part of that goes back to the big ramp ups and ramp downs in shipbuilding, where people my age who learned how to design and build ships because there were people in place who did that and had the experience are leaving the industry. Okay, and so we left a void. And that's not to say there aren't able people in the industry today, but what that means is that we didn't take the time to teach them. And a lot of that was because we weren't designing ships, really. We were building rollover, mod repeats. And so now there's a push to build more ships and build them faster. So to build them faster, again, you've got to have everything lined up. You've got to have the funding. You've got to have a good forecast on a good stable demand signal. A stable demand signal looks way out. Our supply base isn't going to invest in a sale of 4 ships. They're just not going to. But if they knew, and if it was in writing, and if they were contracted to go build components to support 25 ships, I believe that they'd ramp up and they would support.
And so you mentioned some of the skilled labor for design and production up front. 2 parts kind of here in my brain. One is, what are more specific examples of those? Is that outfitting, welding, running cable? And then 2, regardless of sort of what your examples are, like how does your work with SNAME fit into, I guess, driving and educating and building that workforce that is the big bottleneck?
That's a great question. So let's start with the labor piece.
Yeah.
For skilled labor, production labor. Okay, so the production labor, you've got kids coming out of high school today who don't have the same kind of mechanical experiences that we had when we were kids. Honestly believe that. As a kid going through high school, We had machine shops in high school. We had woodworking shops in high school, and we had cars in the backyard that had an engine that you could work on pretty readily. And all that stuff has changed. Right. So kids don't have that basic understanding, and so from the production trade standpoint, you're trying to develop those skills just like you are engineering skills. The piece with SNAME, I've realized that if ships gotten more complex, the engineering talent isn't just naval architecture. The engineering talent is mechanical engineers and electrical engineers and system engineers and computer engineers, and those guys are really good on their topic, but they don't know how to integrate their knowledge with a vessel. They don't understand how a vessel actually operates. And so there's training required in order to bring those people up to speed. When an engineer comes out of college, he knows the basics, the mathematics, he knows the physics, but he doesn't know how to put it all together and design a warship or even a commercial ship. So what we're looking at with SNAME, and we're working with NAVC on this, is setting up a series of mentorship courses to take engineers who are recently graduated, who don't have maritime degrees, to teach them the basic maritime concepts so they know how to apply them. And for engineers who've been in the business for a while but haven't designed a ship, how do you what are the basic 1, 2, 3 kind of things that you have to go through in order to design a ship? So that training module that we've proposed is going to start with machinery arrangement, design, and integration.
So you asked about the SNAME connection, and for those who don't know, the Society of Naval Architects and Marine Engineers is probably one of only a couple of technical societies left around our space.
Exactly.
And
exactly.
you were president of SNAME for a while, have been a long-standing member of the leadership team. How do you see, when you think about, you've done you were in shipbuilding directly for 40 years?
Right.
How many years?
39 and a half.
39 and a half.
Yeah.
And then you now you're full-time working on the edge here, helping with the next generation. What is that? What's it look like success-wise? What's that look like if that goes well?
So if that goes well, to me, designs come together much quicker. Designs come together much better. The quality is there. People understand how to design a ship not only so you can operate it, but so you can produce it and maintain it and repair it. And that's the piece that's missing here today. The pace increases. And so I think those things are the results of this. And I think these engineers become much better prepared to go off and design a ship. They begin to look for new technologies as well. A lot of the design work all the design work is being done in 3D product models now. So how do you take advantage of that product model and all the systems, in some cases, that are connected directly to the product model? So you can do your finite element analysis, you can do your routing, your cable routing, and so on. So it's bringing all that together so that the engineers are more proficient.
It sounds like maybe you're getting some support from the Navy on this initiative. And are you also seeing, so eager to hear about that, but then it's second, are you also seeing interest and support from, say, local and state governments when they thinking about workforce development?
We haven't really started talking about the local and state governments, but I believe that we will. All the local and state governments are pushing STEM programs and skills training, even for white-collar workers. And so I honestly believe we'll get support there. NAVC fully supports this. We haven't gotten the project funded yet, but they want to get this accomplished. And we're already talking about what happens after this first module. And so when I think about SNAME's role in all this, SNAME has years of information and guidelines that have been developed, procedures and policies for how you design ships. Right. They have 4,300 members. Many of them are my age and have been through the industry. They're great mentors, and many of them are willing to stand up and help. So I believe that there's a lot of opportunity in this space.
It's great to, I think, talk about the workforce part a little bit, and I think there's probably a whole different conversation for the shipyard, assembly guys, the welding, all that. I think we're hoping to have a discussion with the Maritime Industrial Base guys down the road about that.
I hope you do.
Which will be really exciting.
Yeah,
so maybe we pivot a little bit and step back. Like, you've helped build some of the most complex ships that, humans have ever created, right? The submarines, the aircraft carriers. What's the hardest technical challenge you faced?
Wow. Believe it or not, I still think the hardest challenge is getting the engineering done and getting it down to the deck plate so you can go build the product. I've honestly seen craftsmen, if you give them the tools that they need to do a job, they'll do it.
Yeah.
Now, does that mean that they make mistakes or don't make mistakes? Yeah, they make mistakes. But if you give them clarity and information and all the information they need to do the job, they'll knock it out of the park.
Is there any digital tooling that you're excited about right now that's helping, let's say, push that information down to the deck plates?
Yeah, I am. For sure, I mentioned the product models. I think that the 3D product model systems that are out there today are getting more and more capable. They're a lot better than they were when I first started. When I first started, we had a homegrown system. You could make a 3D product model, but you couldn't print it. You had to take a photograph of it, wow. And then you had a 35 millimeter slide. So today you can do so much more with those software products, and so I'm really, really excited about that. I believe that those products with AI, and we got to be careful of AI, but those products with AI and with some of the other tools that are coming on the market today, you could get to the point that you design a product and you do the plan at the same time. And, what comes out of the box, if you will, is not only a design, but a plan, fully engineered product. We're a ways off, but I think that we'll get there one day.
Do you think, talking about shipbuilding, just in the greater sense, what do you think is what's the most significant driver relative to how fast you can build?
I really think it's footprint, and I think it's people, and I think it's parts. I really do.
When you say parts, you mean like supply chain?
Yeah, supply chain, getting parts from all of your suppliers. The other piece, though, is simplicity, right? If we look back to World War II and the work that was done, by the U.S. shipbuilders and a guy named William Knudsen, who came in under Theodore Roosevelt, and kind of took a car building approach to building everything for the war, right? Everything from trucks and jeeps and cars to tanks and to ships. And so we came up with the Liberty ship and the Victory ship. So if we could come up with some kind of design like that for our warships, and if we do many copies of the same design, I think pace increases. When you have change from vessel to vessel to vessel, it slows things down. And we all know that it doesn't matter how good the engineering is, when you have change, you create errors, potential for errors anyway. Yeah. So it really slows down pace.
The thing I always ask, and I asked the flag officer this morning, but the requirements process, especially from the Navy, caused a lot of problem. Have you looked at what happened to JSIDS last week, and do you think that'll have a positive impact on sort of the ship design requirements process and the flow down to whether we can have a simpler design?
Yeah, I did take a look at that, and I do believe that with a simpler design, and again, getting the design defined and completed before you get started, and making it as simple and as producible as possible, then you get the pace.
Is there any design in the U.S. that you're aware of? And I'm not at all, but I'm not at the right level of knowledge here. But a design that's in the U.S. that's active that could be really mass producible or close to it that you're excited about?
Well, the Virginia class was one of those. Virginia class came out of the box, spending years on the design and years on the planning. And the first ships out of that class really came out quickly and came out well. So I think that was a model program. And if it was replicated, I think you could do that with a lot of different programs. The DDG 51 program is another one of those, where the Navy made a decision on a ship design. It took a while to get the design locked down, but they got a lockdown design. They had two builders, and both builders were building the ships exactly the same way. And so they would buy a flight, right, 10, 12 ships, as opposed to buying one or two and then making a change.
We talked about the requirements, and I won't take the bait, Austin. But Rick and I actually have some experience working on requirements type issues together in the past. It's been a long time.
It has.
Trying to narrow that down. But I think if we take the requirements out of the mix for a second, what do you think is if you could just pick one bottleneck to go fix that would make the biggest impact for the industry at large, what would it be?
That's a good question. I still think that the biggest bottleneck that we need to relieve is the flow of materials, the supply base. I really do.
Do you know enough about what's happening with MIB, the Maritime Industrial Base effort, to say whether that's helping? Can you tell?
I don't know. I mean, I know a little bit. I've been on the fringes of that, and I have a good idea of what they're doing. I think it will help in the long run, but near term, it's gonna take a while to help.
And is it because the supply base is just sort of atrophied over time, or have we become too dependent on things from overseas? Where
I think the supply base has gotten narrow, right? The supply base used to be much bigger when we were building more programs, building more ships, more shipyards. We had commercial ships and warships being built in the United States. And over time, with the complexity, the difficulty of the design, more and more of the manufacturers have gotten out of the business, or companies have consolidated. But there hasn't been a forward-looking demand signal good enough to cause those people to put a bunch of money in their businesses. And so it's the same business, maybe with some expansion, and they have the same labor issues that the shipyards have. Their people have left. There's new people on board. And so I think it's really a bit of an atrophy, in the supply base.
Do you think the reconciliation money definitely creates a spike in demand for naval ships? There's not really yet, I'd say, fiscal incentives to greatly increase demand for non-naval Jones Act ships. But will the reconciliation dollars, I guess, be enough to drive sustained increase in demand to help the supply base over a long term?
I don't think so. I think it's going to take a lot of money. I really do. I think you got to have a demand signal first, and then you've got to have a tremendous amount of money to build up the supply base. The suppliers are out there. The suppliers, I think, would be willing to do what they need to do in order to be better able to provide parts and so on. But they've got to have the incentives. They got to have some guarantee that the work's going to be there.
Yeah, right.
And I think standardization too. They're going to do a whole bunch better if they can build, compressors or some kind of other part for us for multiple ships or multiple programs over multiple years.
I always think about the there's that story about the $50,000 toilet seats that the government was buying. And I always chuckle about that example because if it was true, what we don't talk about is the fact that it was a very bespoke, unique toilet seat that they made one of every 5 years.
Yeah, and so of course you would charge the same amount of money for that.
Right.
Because you're gearing up once to go build that thing and then you're done. So I'm convinced it's very much like the auto industry. We don't build ships like they build cars, and we never will. But, during World War II, we came pretty darn close. And we did that because we were building a standard product with simplified parts, and we had a great supply base. Everybody was lined up to produce.
I know you and our teammate Rylan were talking about the Reagan-era boom a little bit just before this, and it's interesting for me to think about, all right, there's the World War II era where I think we really sort of made our name of building American maritime power. And the Reagan boom was not the same, right? It wasn't the same existential moment. But that's the legacy we're left with now because that's the sort of tail that we're running off of, right? Mm-hmm. We still have some of the people. We still have some of the ships. Do you think the ships during that period were as mass producible and were as simply designed? Or was that just an era where we spent a ton of money and we had many exquisite ships? And if so, kind of what are the lessons there? And can we ever even go back to the World War II era?
I think you could get back to near the similar pace to the World War II era, but it's going to be a different ship. And we'll talk about that in a second. I would tell you that at that time, the warships seemed pretty darn complex, but when you compare them to today, they really weren't. Mm-hmm. We were building at a much faster pace. We had a lot more people in the industry, both from the supply base standpoint and at the shipyard. And we had people who were experienced. People were building these ships based on their experience in building the last ship. Kind of like, I remember when I was at Ingalls, they told us about the cruiser program where, the workers were building the same part or the same module in the same footprint of the shipyard that they built them all in. And you didn't even need a drawing. Right. You just got your pallet of parts and you went to work. That's what we got to get back to.
thinking about, we were talking a minute ago about, the processes to do, how we built Liberty ships back then, and highly repeatable is a theme. Are there emerging technologies that you think are going to help us, turn the corner? Things that will, and I'm leading the witness a bit. I don't mean to say robotic welding, though I'm happy if that's the answer. Are there things that you see coming down the pipeline in terms of technology that are really going to make a big difference for us in terms of volume and throughput?
Some of that's already here. Some of the robotics are already there. There's double bottom panel lines, automated panel lines, and so there is automation that's already out there that we could put in place in shipbuilding. Same with pipe construction or fabrication and assembly, right? But that's such a small part of building the ship. The steel fabrication piece, building units, certainly we could take an awful lot of time and a lot of cost out of that, but you still have to assemble the ship. You still have to pull the cable. You still have to install the piping and so on. So I don't know where the automation comes in there, except for maybe some automated welding, closing up butts and so on. I do think, though, that this industry begins to move away from some of the more complex warships and these warships that are designed to do a lot of different things on the same vehicle, as opposed to having a ship that can do anti-submarine warfare and a ship that does something else, right? The ships are being designed to do everything, and so they're more complex. But with autonomy, I believe you could get to the point that you can have more repeatable designs, faster builds, things that are more specific for the mission, and easier to build and cheaper.
So purpose-built.
Purpose-built. Yeah.
Makes a lot of sense.
A friend of mine who is working on setting up a new line was explaining how hard it is to get panel line equipment. It seems to all come from like exquisite Northern European manufacturers, and there's 3-year lead times. And of course, you can get it from China in 6 months, right? But is there any way around that? I mean, to increase capacity, you have to go through those suppliers, right?
You do have to go through those suppliers. You do. And there's not, as you said, there's not very many of them.
Yeah.
I know the guy you're thinking of. We should have him on the show because his answer will be, we're going to do something else.
Yeah, that's exactly right.
I think he can't. I think he wouldn't be able to talk about that on the air yet.
Yeah, right.
I think we're holding fire on him.
Got it.
Yeah.
You need to bring him on.
There's some cool stuff brewing in the industrial base, though. Yeah. Have you seen any tactical examples in the field recently of new tech being applied to our space, to shipbuilding, or even to solve a specific type of problem, right? Be it welding or we look a lot at design tools because we agree that a lot of this is very labor intense, and therefore you just need to have smarter, simpler design.
So I think for sure there is a lot of new welding equipment out there, and the connectability between the welding equipment and back into the product model. Being able to take a digital design and dumping it right into your production data, and then the production data right down to the shop floor, really, really makes a lot of sense. And so I've seen that being applied in multiple shipyards, both in the United States and overseas.
What's your digital design software choice?
Ooh, I can't tell you that.
Okay.
We could probably narrow it down pretty well.
Yeah, we can narrow it down really, really quick if you want to.
Every time, Scott. Every time we're on a call with a new shop, Scott's like first 3 questions is what's your design tool for this?
Yeah, what's your design tool
for that?
Oh,
and then why is that your choice?
Yeah.
Well, it's actually a really interesting point because shipbuilding is unique in a myriad ways, but one of them is that there are really only a couple of platforms here that everybody uses, and it turns out those are not the same platforms that everybody else uses in emerging tech, and so that's a really interesting intersection right now.
It is.
Rick, let's turn to current events a little bit. What are you watching for? And we talked about Congress a little bit, about the requirements reform a little bit already, but what are you watching for kind of in the political and news environment right now to see where we're turning a corner, where things are changing, improving, or getting worse, to tell you which way the industry or parts of it are going?
Yeah, so last year was it December that the president announced this SHIPS program, right? And then the first of the year they modified it just ever so slightly, and that's really exciting when you read the legislator.
Wait, so say that part again, but it would have been last year Congress put it out in December, and then the president put it out once he was in office.
That's right.
Yeah.
The president put it out when he was in office earlier this year. And the requirements of that act are exactly the things that we've been preaching or been preached to for years, right? It's stability of demand. It's setting a design that it's producible. It's let's go out and go build ships. Let's go fund the supply base. Let's fund the shipyards so they have the equipment and the tools they need to increase pace. And it's also funding training. So I'm really excited about that. The second piece, though, is we've been hearing discussion about working with the Koreans for several months. And people my age remember that we brought the Japanese over, people from IHI and other shipyards to come over and work with us, at least at the big shipyards, to learn how to design for production and how to set up our shipyards to flow much, much better, right? And so now we're talking about bringing in the Koreans, and I know that President Trump met with President Lee from South Korea yesterday, and it sounds like it was a really good discussion. $150 billion potentially worth of investment in U.S. shipbuilding, where the Koreans will come over here and help us, to learn some of the processes, how to improve our processes for ship design and construction. I think that's going to be very powerful.
And I'm still trying to figure out what the $150 billion, how that's substantiated. I think it's their bank would help finance it if there was a deal between two companies. Is that what you guys are seeing?
It's not clear to me either.
Okay.
Yeah,
I'm not really sure how that all works.
The way my read is that the Korean angle on this is we will invest in Korean companies doing things in the U.S. around shipbuilding. And we know a couple of the players. Today's been a very busy day for MOU announcements again.
Yeah.
So
I think it's going to be. It could be very, very good for the United States and for Korea. Korea is very interested in getting into the U.S. shipbuilding business. We have some technologies, I believe, that they'd like to have, and they have some skills and capabilities that they learned over the years. The difficulty for me being, having been in this business for a lot of years, is we all remember, or we all know about World War II. A lot of the technology and the techniques and the ideas that were put together to mass produce back then were the things that the Japanese learned from us, and then the Koreans learned from Japan, and now we're learning it back again.
what do you think the role is of when you think about the U.S. government's involvement? I think the Korean government's involvement in building up those companies is well known, in terms of highly incentivizing the chaebols, or how you say that. Do you feel like the SHIPS Act is leading us in a similar direction, maybe?
I do feel like it is. And I think back before Reagan, we were incentivizing some of our shipbuilding in the United States. But when Reagan took over and made a decision he was going to fund a growth in naval shipbuilding, go from 460 ships to 600 ships by 1990, I think it was. So it was like a 10-year period, right? He took away those subsidies and used that money to finance the naval shipbuilding. And the result of that is a lot of the commercial shipbuilding here consolidated or went offshore. So I do think that you'll see some of that with this new agreement.
Yeah. Do you have a favorite provision of the SHIPS Act that you're pulling for that you hope gets into the I have one that you hope gets into the NDAA?
Yeah, skills development.
Okay.
Yeah.
Okay.
I mean, they're looking all the way down to high school level.
Yeah.
And I think it's great.
Yeah.
I really do.
That makes a ton of sense. I met with a state government recently who has really good messaging around their maritime training program. But when we peeled back the onion and we sat down and talked about it, it was just regular economic development tools that are just labeled really cutely as maritime manufacturing. And we had a little talk about that. But
so what's your favorite?
Mine would be the tax credits. I don't like taxes.
Tax credits.
I'm not into those. Yeah. Tim pays the taxes around here for us. So.
Yeah, good.
I'll tell you what. I think one of there's a lot of MOUs in the news today. There's also a lot of new hats.
Wait, what's your favorite MOU that's in the news?
Yeah. I'm not sure I have a favorite. What I'm looking forward
least
to
favorite?
they're all about the same to me, because it's when you turn that understanding into an agreement that things start to get serious.
There you go. Yeah.
And so I think it's a good spirited conversation, and we're now printing new hats to make American shipbuilding great again, right?
Mm-hmm. Yep.
The thing for me about SHIPS Act, I don't have a favorite element of it, but I will say that through my entire shipbuilding career, it wasn't until last year that you could talk to a random person on the street about shipbuilding and they knew what you were talking about.
You're absolutely right.
No one cared about this industry until 6 months ago.
And what's interesting, even more interesting about that is that these yards are huge. They take up a big part of a city, and there's people in the city that don't have a clue what they do over there, except for mess up the traffic at starting time and ending time. But shipbuilding is huge for this country, and always has been. So there's something about the Ships Act, I believe it's in the Ships Act, that talks about the country that has the best navies are usually the leading countries. And if you look back to way back, in the time when Britain had the biggest fleet.
Right?
Yeah. I mean, they were the ones that were kind of leading the world.
I saw a funny stat. I'm not sure if it's true, but I saw a funny stat that the United States Air Force is the largest air force in the world.
Is it on TikTok or?
No, it wasn't. I don't.
Could be Chinese propaganda.
I don't use TikTok for reasons that we can't talk about. But the second largest air force in the world is the United States Navy.
Yeah,
I believe that.
Yeah.
I believe that. We always used to hear that the Navy has more airplanes than the Air Force, and the Army has more boats than the Navy. So I suppose that's true.
Okay, lightning round?
Yeah.
Yeah? Okay. So, Rick, what's an underrated shipyard or maritime company that you're excited about?
Yeah, I don't know.
Are there too many overrated ones?
Yeah. Let's go to the next question.
Okay. All right.
I had one in mind, and I thought, I don't know.
Besides Blue Water Autonomy. Most interesting DoD program to watch in FY26?
I think Autonomy. I really do. Autonomy it's beginning to be talked about. I mean, there's been people working on autonomous vessels for a short time now, but it's finally being talked about. So I think that's going to be a program to watch. Yeah, I really do.
So on the flip side, what's a technology that you think is overhyped?
Generative AI. I just don't see that happening.
Well, that's what wrote all these podcast questions, so that explains part of the issue we're having here.
It's going to help us splice all this video together afterward.
That's right.
Are you seeing, can you just talk maybe just for another 30 seconds about that, about generative AI being overhyped? And are you're not seeing much on the, from our young people? Are they using it too much, that kind of thing?
Yeah, I think people are trying to use it too much. We're doing everything from holding meetings and having an AI translator listening to our meetings and then writing the meeting notes for us, and in many cases really screwing them up, to kids writing papers using AI. And I think there's a place for it. There's absolutely a place for it, but I don't think you should be doing papers, and I don't think you should be doing research reports and so on using AI. So it's my old-fashioned take on that. Go get a dictionary. Yeah.
Okay, what's an
encyclopedia?
There you go. What's a tip besides that one for someone looking to break into the industry?
I really think that the best place to go with in the industry is into electronics, robotics. I really do. I think that there's a huge future there, and it gets back to this autonomy piece. I really do think there's a huge future there, and people who are studying and looking at emerging technology in that space and looking for ways to disrupt what's already out there, they're the ones that are going to really move ahead.
And so thinking about robotics and electronics, are those, is that also the area where you would tell, someone trying to get into the industry what they should study? What does the industry need the most?
Well, I'd be remiss if I didn't say we need naval architects and marine engineers. Yeah. We do need those. But I really think get into robotics, get into electrical engineering, system engineering, computers maybe, but I really think it's robotics, system engineering, electronics, electrical engineering.
Yeah.
Where can listeners follow your work or support your efforts? You talked about, I think, a couple different lines of effort here already.
Society of Naval Architects and Marine Engineers. We have a symposium every year. This year it's in Norfolk, October 29th, 30th, and 31st. They cover a myriad of topics. Registration's open now. I'd get into that program, and you'll hear discussions just like I'm having here today.
So if you had 30 seconds with someone from the White House, the Pentagon, or any other significant industry leader, what would you say?
I have to be nice, right?
I don't know. I think that might be, it would certainly be in character for you to be nice, but not from this industry. We're not necessarily nice.
I would tell them, look, this industry can produce, we can make this industry produce anything, not just ships. But it needs clarity and demand, and it needs funding, and it needs a darn good leader. And so if you go back, and I'm sorry to go back in time, but Knutson, William T. Knutson, or William D., whatever it was, he had a vision, and he had support from a government that had the funds. They had the right funds to go do what needed to be done. He had a vision for what needed to be done, so therefore he had a plan, and he rallied people together around the cause. And I think that this country can produce. We can produce commercial ships. We can produce warships at a much faster pace if we know that there's a demand out there, if we know that there's funding out there, and if we're being honest with ourselves about our current state. This is where I am today. This is where I want to be. There's a stepping stone path to get there. We can't flip a switch and get there. And neither could they in World War II. So that's what I would say. Give us a leader.
That story.
Give us a leader.
I love it. I love it. And that story is very popular in this office too.
Good.
Yeah.
Yep.
Not as popular as the news today that, what did we hear just before coming in there? That,
Well, I think Rick was the one who was so excited about it.
Yeah, you were mentioning you were really fired up about that news pop culture story.
With the Kansas City Chiefs guy.
And Taylor Swift.
Travis Kelce. Yeah.
Yeah, and some singer.
Travis Swift.
Yes,
Sorry, Travis Swift.
Travis Swift.
Yeah.
I was aghast. I was just talking to her last night, and she didn't say a word about it. So it really, really surprised me.
I love
We're
it.
good friends.
I love it.
That's great.
I love it.
Okay.
Well, we can't tell you how much we appreciate you coming to join us today. Great conversation.
Thank you. Thank you so much for inviting me. I really enjoyed it.
Yeah, we're really bullish about where things are heading with the fleet.
Yeah, well, you should be. I think you guys got a great opportunity here with this business, and so I'm excited to see it go.
All right. Thanks, Rick.
Thank you.
Thanks.
I would